the variance of the mean is an important quantity for one to inspect. We can calculate formally on how to on that with potential correlated variables. So that's the definition of mean. Since the sum of variance is variant sorry the variant with a constant in the front can be squared outside, and you have this. And here recall the sum of variant with correlated function with this will be like that, and then the covariant we're recall notice the sum is from 2 I greater than j. 2 is just to avoid the double count. It's just like a counting twice of greater than j and less than j. So we can replace this as just correlation or just ij. But we just for this we'll just assume all the quantities are just rho ij equals rho. So for this, you can assume just have 1, 2, 3. There's it's like sum altogether. It's a sum of the normal sequence sum, the series sum. You have n items and n minus 1 items with starting with number 2, because the j equals, you have to have I equals 2, j equals 1, then you have this. You have 1. So it will be n minus 1 plus 1, and then n total divided by 2, n minus 1. So we have this. We have n variant, and then multiply this in those two together. We'll have n minus 1. Take the n out as a common factor, and then we end up getting this, and put this back in. We have 1 over n squared and n plus n minus 1 rho, and multiply n on both sides. We have this eliminated, and then divide this whole thing to the bottom. We'll see the reason why very soon. We have this. For rho equal to 0, it's very simple to see this is 1. So we have n 1 over n, and this is for uncorrelated data. For rho not equal to 0, we will have an effective. Assume that so effectively they have an effective amount of uncorrelated data. So we ended up have this function with n effective as n over 1 plus n minus 1 rho.